Lines and Linear Equations, Chapter 4, Lesson 1, Part 1. First, some vocabulary. Direct proportions are represented in linear equation where x is directly related to y, just like the examples we've been talking about this past week. Direct proportions are shown on graphs by a straight line that will pass through the 0, coordinate and have a constant rate of change. The rate of change is how fast the line moves. This can be calculated by y divided by x from the coordinates. For example, a line with the point 510 has a rate of change because 10 divided by 5 is 2. So we have some examples here. These are both direct proportions. Again, because you see the line is passing through 0, here and 0, here. We can also test this by checking a couple points on the line and seeing if they have that same rate of change. So here I picked 0.22 and 2 divided by 2. So I'm just doing that division problem. Y divided by x is 1. And then another one here, 4 is the point. And again, if I do y divided by x, it's equal to 1 still. And any point on that line is going to have that same rate of change. In number 2 here, I can try this point here. Again, pick easy points that meet at exact coordinates. So this point is 10, 20. And then I have another point here, 40 at 20, 40. So I'll check that it's a direct proportion by again doing y divided by x. 20 divided by 10 is 2. And 40 divided by 20 is also 2. So that these two graphs both have a rate of change of 2. So these two graphs here, remember I said that for it to be a direct proportion, it would pass through 0. So this line here ends at about 0.3. So right away, that's not a direct proportion. We could also check by using some coordinates. Here I have 1, 4. Again, my x is listed first. 4 divided by 1 equals 4. And then another point is 6. I'm sorry, I'm saying that backwards. 3, 6. And 6 divided by 3 equals 2. So because these are not equal, this is not a direct proportion. Number 4, we can check. Here we see 0, so that's a good indicator. Now let's test it with a couple points. Here we have 4, 2. Again, I'll pick another easy one. 12, 6. If I divide y by x, I have 2 divided by 4, and that equals 1/2. And then I have 6 divided by 12, and that also equals 1/2. So this is a direct proportion. So your objective here in this lesson is to be able to calculate the slope of a line. The slope of a line is another way to say the rate of change. This is calculated by the change in y divided by the change in x. So to do this, you have to pick 2 points on the line. So if we had a graph, we were like from number 2 in our previous example, we had 2 points here, 0, and 3, 3. So again, the points we were using were 0, and 3, 3. I first want to label each point, just point 1 and point 2. It doesn't matter which one you label as point 1 or point 2, just as long as you keep them in the right order when doing the actual division problem. So again, point 1 is going to be 0, and point 2 is 3, 3. So to calculate the change in y, we take the y from point 2, so that's the 3, and then we subtract the y from point 1. So 3 minus 0, which of course is 3. And then to calculate the change in x, we're doing the same thing. We start with point 2 and subtract point 1. Again, it's important that you go in those order and don't switch them. That's where a common mistake is made. But again, 3 minus 0 is 3. So that would look like 3/3, or what I have here. And then we would actually do the division, which is 1. So the slope of that line in graph 2 is 1. Slope can be used to compare equations, especially unit rate, like cost of things or how much something weighs per pound, not weighs per pound, cost per pound, or speed, things like that. The larger the slope, the faster the line. The smaller the slope, the slower the line. That kind of makes sense if you think about the slope of a hill. The steeper the hill is, the faster you would go down it if you were skiing or sledding or something like that. All right, so using slope to compare. So again, we have two graphs here. The graph is the speed of toy trains that are being compared. So we can just look at these lines here, which is steeper or which would be a higher hill. So this line in train A is much steeper. It goes from bottom to top a lot quicker than in train 2. It's a little slower rise up. So just by looking at that graph, I can see that train A is actually faster because it has that steeper slope. You can check that with calculations by calculating the slope, rise over run. They use rise over run, which is what I showed you to calculate before. So they use 0.00 and 0.130. So the change in y is 30 minus 0. The change in x is 1 minus 0, which leaves us with 30 over 1, or what they have here, which of course simplifies to that slope of 30. Same thing, speed of train 2, they used, again, 0, 0. If you have the option of 0, 0, always use it. It makes your calculations a lot quicker. And that 0.420 that's labeled here. And then they're calculating rise over run or slope again by doing change in y. So this is 0.1, this is 0.2. I do the y from 0.2 minus the y from 0.1 and the x from 0.2 minus the x from 0.1. And that, of course, would be 20 over 4, which simplifies down to 5. So you see we have a larger slope in point A, which again means it's moving faster. So just to reiterate, the slope for the distance moved by toy train A is 30. So the unit rate is 30, or the speed, 30 millimeters per second. And the slope for the distance moved by train B is 5. So the unit rate is 5. So toy train B has a slower unit rate. I was talking that A had the faster one. That's an example of make sure you're reading the question to know what you're answering. I would have got that wrong if I just filled it in. So again, they wanted to know which one was slower, the smaller slope equals slower. All right, so let's try, we have some speed of ball bearings. So we're just comparing here. So we have speed of ball bearing A. I'm going to use my 2 points. Again, 0, 0 is an option. So I'm going to use that as 0.1 to make it simple on myself. And 0.2 would be 5 and 250. If they label points for you, use those points. It's always meant to be a little easier. So I'm going to calculate it by doing y2, 250 minus y1 of 0, and x2, and the x from 0.1, which is 0. So that would be 250 over 5. And then if I do that division, I actually get 50 millimeters per second. And then I'll do the same for ball bearing B. My 0.1 is going to be 0, 0. My 0.2 will be for 100. Okay, so again, my y from 0.1 minus my y from 0.2 divided by my x from 0.2. I'm sorry, I said that backwards. Y from 0.2 minus y from 0.1, and then my x from 0.2 minus my x from 0.1, which is 0. So I get 100 over 4, which would, I cut that line off, would be 25 millimeters per second. So ball bearing A is faster because it's moving at 50 millimeters per second. And ball bearing B is only 25 meters per second. So I can fill this in. The slope for the speed moved by ball bearing A is 50 millimeters per second. So the unit rate is 50 millimeters per second. The slope for the speed moved by ball bearing B is 25. So the unit rate is 25 millimeters per second. And again, they're asking for faster speed. So we're picking the higher number. Ball bearing A has a faster speed. Again, I'll just put this as a note. You might want to add it to look back on. Larger slope equals faster speed. So I'd like you to give number 6 a try by yourself. Again, first calculate the slopes of both by doing the rise over run, or the y from point 2 minus the y from point 1 divided by the x from point 2, subtracting the x from point 1. I'll help you out and give you your points. For point 1, you'll use 0, 0 on this one, and point 2, you'll use 8 and 640. And then on person B, you'll use again 0, 0 for point 1. And for point 2, you'll use 4 and 380. Again, keep in mind they're asking who types at the faster rate. Pause now, find the slope, come back and check your answer in a moment. So I'll just show my calculations for slope here so you can see what I've done. And hopefully you did the same thing. Not 80, Miss Rico. Okay, so 640 divided by 8 would simply be 80. And then we would have 380 divided by 4 would be 92. Just prove that with my long division. I should say check that with my long division. 4 goes into 38 9 times. I am left with 20. Oop, I made a mistake. I'm glad I checked. 4 goes into 25 times. So this is incorrect, and this would be 95 words per minute. That's the label, words per minute. So which person typed faster? Who has the larger slope here? Person B typed faster. So here they're just, again, reviewing how to find slope of a line when given 2 points. We've been doing this on the last couple ones, so it's just a review. But in graph A here, they label 2 points. We have 0, 2 and 2, 5. Okay, so we'll use 0, 2 as point 1 and 2, 5 as point 2. So again, you should write this down as much as you can until it's committed to memory. The y from point 2 minus the y from point 1 divided by the x from point 2, subtracting the x from point 1. So that's the y from point 2 is 5, then from point 1 is 2, the x from point 2 is 2, minus 0, and they would get a slope of 3/2. Please feel free to leave them as improper fractions. Again, slope as an improper fraction looks better and just makes more sense than actually converting it to a mixed number. If you want to make it a decimal, that's okay. But again, I really just suggest leaving it as an improper fraction. Here we have another example. I want to definitely show you this one, and notice how this one goes down when we're moving from left to right. When you see a slope going down in that direction, down, this is something you should write down from left to right, you will always have a negative slope. A negative slope is fine. Don't think you've got something wrong if you get a negative slope. So again, we use point 1 here of negative 4, 6 and 0.2 of negative 1, 0. So I'm going to use my y from 0.1. Well, they actually switched the points, but I'm going to show you it works either way. Or no, they didn't. My y from 0.2 is 0 minus my y from 0.1, which is 6. And then my x from 0.2, which is negative 1, minus a negative 4. So 0 minus 6 is where they get that negative 6. Negative 1 minus negative 4 is a positive 3. So then they do the actual division. Negative 6 divided by a positive 3 is a negative 2. So the slope is negative 2. And again, the line going in the direction it does confirms that your slope should be negative. All right, so number 7 and number 8. I'm going to give you the points again that I'd like you to use. They're labeled here, but I'll label them for you, and then I'd like you to calculate the slope. Again, write this formula down. Y2 minus Y1 divided by X2 minus X1. That just means from point 2 and from point 1. So point 1 here, use 0, 0. And point 2, use 2, negative 4. And then for number 8, point 1, I want you to use 0, negative 1. And point 2, use 6, 5. Pause, calculate the slope, come back and check your work in a moment. So what you should have done is negative 4 minus 0 over 2 minus 0, which is, of course, negative 4 over 2. And if you do the division, your slope would be negative 2. Again, you should have realized your slope would have been negative because it's going down in that direction. For number 8, you should have done 5 minus negative 1 divided by 6 minus 0, which is 6 divided by 6, which of course is 1. So you'd have a slope of 1, positive 1, because your line is rising. It's going up towards the right. It's a positive slope. So again, like I said in the beginning, we can use slope to compare two items. So we have a tap, a sink, a faucet here, tap A and tap B. We want to know which one is, moving faster, which one's filling up the tank faster. So in order to compare, what you're going to do is calculate the slope of each tap. So again, you're going to use 2 points. Again, if you see a 0, 0, always use that, all right? So point 1 would be 0, 0. And point 2, pick an obvious one that hits right on a mark. And we'd have point 2. That one I picked is 330. We could have done any. Then I just calculate slope and do 30 minus 0 over 3 minus 0, which is 30 over 3, which simplifies to 10. And then for rate B, again, I'm going to use 0, 0. And we'll pick the highest one in this case, 5, 100. So 100 minus 0 over 5 minus 0 is, of course, 100 over 5, which would equal a slope of 20. So the one that has the faster slope, which would be tap B, is that water is filling faster. So we already did this on the last page, but it said find the slope for point A. We figured it was 0.10. So not 0.10. So A's equal 10 millimeters per second that it was filling up the tank. And point B, again, we calculated that was 20 millimeters per second. So we just fill in that information. Then it said which tank or which tap is able to fill it faster. Because it's asking which one is faster, we pick the larger slope, which was tank B. Let's do this one on our own. It says when two metal rods of the same length and width were heated, the temperature increases steadily until the rods reach their melting point. The graph represents the temperature in Celsius of the iron rod over time in minutes. The temperature of the copper rods is 247 degrees over the same length of time. So they gave us the slope of the copper rod. It's the same, it's after the same amount of time. So after 4 minutes, it's 247 degrees Celsius. Or I'm sorry, that's just the slope of the copper rod. So they already give us that information. So now let's find the slope of the iron rod. And pick our 2 points, 0, 0. And they give us a nice one here for 292. So I'm going to calculate my rise over run, which would be 292 minus 0 over 4 minus 0, which is 292 over 4. I'm going to do that one with division, long division, instead of trying it in my head, so I don't make a silly mistake like last time. Okay, so it looks like our slope is 73. So that means it's heating 73 degrees Celsius per minute. So I was reading that a little incorrectly before about the copper rod. They say it heated to 247 degrees over the same amount of time. So basically what they were saying was that our other point was for 247. So that would be 0.2. And 0, 0 again is 0.1. It all starts at the same temperature. So we would do our calculations by doing 247 minus 0 over 4 minus 0. I'd get 247 over 4. And this one I can tell right away is not going to be, excuse me, it's going to be a decimal. That's okay. I'm just going to keep doing my division. 4 goes into 24 6 times. 4 goes into 7 once. I'd add a decimal and a 0, bring it down. 4 goes into 37 times. Again, bring down a 0 until I'm done. 4 goes into 25 times. Now we're finished. So this one is about, well, it's not about, it's actually 61.75 degrees Celsius per minute. So which rod is a better conductor of heat, or which rod heats up faster? That would be that iron rod, because that one heated up again at 73 degrees Celsius per minute. Okay, here we are tracking the speed of 2 meteorites. So how many miles they travel per hour. Again, I know that's what they're asking because they label our axes of our graph so nicely. So first, find the point slope of graph A, meteorite A. So my 2 points are 0, 0, and 5, 750. So to find the slope, I'm going to do 750 minus 0 over 5 minus 0, which is 750 over 5, which would be 150 miles per hour. And then this got a little cut off, but that's all right. I'll use a different color maybe so you can see better. So for meteorite B, same thing, 0, 0. And then our other point here is 6, 720. So I would do 720 minus 0 over 6 minus 0. 720 divided by 6 is 120 miles per hour. So just looking at it, looks like meteor A is moving faster by about 30 miles per hour. So C, they asked the question. Remember, let's just put our notes here so we don't forget. A moved at 150 miles per hour. B was 120 miles per hour. So it said they're asking which meteorite has the greater mass. So this one is kind of a tricky one. It says the distance moved by the meteorite depends on the mass of the meteorite. They don't really say this to you, which they should, but the larger the meteorite, the faster it's going to move. So meteorite A has the greater mass because it is moving faster. I did erase that work shown, but before I end the lesson, again, I just want you to commit this calculation to memory to find slope. Slope is the change in y divided by the change in x. Those little 2's and 1's by our x's and y's are just telling us which point we're using. You can do great at this. Just keep practicing. Make sure you are keeping your points in the same order. I can't emphasize that enough.